A wooden satellite has survived more than 3.5 months in space, which is much longer than expected. This opens up a new era for building spacecraft. A team of Japanese scientists have just made history by launching the world's first wooden satellite into space. After 116 days in orbit, this little satellite finally re-entered the Earth's atmosphere where it was supposed to burn up, but not before sending its final signals back to Earth. During its time in space, the satellite orbited the Earth 825 times, traveling approximately 35 million kilometers. The main reason behind launching this wooden satellite was to explore the use of wood in space exploration. Wood is a fantastic material known for its low cost, lightweight, and excellent strength-to-weight ratio. However, it was NT until recently that 3D printing technology advanced to the point where it could create intricate wooden components capable of withstanding the extreme conditions of space. It also boasts an incredibly high radiation resistance, making it perfect for withstanding the harsh environment of outer space. In 2017, they launched a CubeSat named Cube 2, which carried a small wooden board into space. If you find our videos helpful, please support us. Additionally, the satellite had a camera and a thermal sensor that were used to monitor the condition of the wooden surface in space. However, Cube 2 didn't have a propulsion system, and it simply acted as a secondary payload along with other experiments. Each step must be carefully executed to ensure that the final product is strong enough to withstand the rigors of space travel. The satellite's development was led by a professor emeritus at the University of Tokyo, who is also the founder of a company specializing in woodworking. They ultimately created a design that resembled a box with rounded corners to minimize air resistance during launch and orbital maneuvers. This is because the density of wood can vary depending on factors such as its origin and how it has been processed. Inaccurate density measurements would affect the structural calculations, potentially leading to catastrophic consequences. They'll be equipped with a camera capable of capturing images of space debris and transmitting them back to Earth. Traditional spaceships are often made from materials that are both expensive and harmful to the environment. On the other hand, wood is a renewable resource that is much more cost-effective and eco-friendly. Moreover, wood doesn't require any special processing to function in space, unlike metals which need to be coated to prevent corrosion. This information will help track the movement of space debris, which is crucial for ensuring the safety of spacecraft and astronauts. As we continue to explore the vast expanse of space, it's essential that we do so in a sustainable and efficient manner. Don't forget to subscribe for more updates on all our latest videos. Thanks for watching, and we'll see you in the next one. The success of LignoSat shows that it is possible to create innovative spacecraft using eco-friendly materials without compromising on quality or performance. One concern is the potential for wood to absorb space radiation, which could affect its structural integrity over time. To address this, JAXA plans to conduct further research on the effects of radiation on wooden materials. Another challenge is the difficulty of recycling wood after it's been used in space. Unlike metals, wood cannot be melted down and reused. Therefore, it is essential to design wooden satellites in a way that minimizes the amount of waste generated during their construction. To overcome this, the team used advanced X-ray computed tomography technology to obtain detailed internal images of the wood. By analyzing these images, they could accurately determine the density of each component. To address this issue, the team developed a unique method of integrating parts without the need for adhesives or screws. As technology advances, it'll become easier and cheaper to build them, making them an attractive alternative to traditional spaceships. Despite facing technical challenges and skepticism from the scientific community, the team of Japanese scientists persevered in their mission to create the world's first wooden satellite. Their dedication and hard work paid off when the satellite not only reached orbit but also survived 4 times longer than expected. Who knows? In the not-so-distant future, we may see entire fleets of wooden satellites orbiting the Earth, helping us explore the vast expanse of space in a more sustainable and cost-effective way. Because the satellite lacked a sophisticated attitude, determination, and control system, it was crucial to ensure that it was placed in the correct orientation during launch. Otherwise, it wouldn't receive sufficient sunlight to power its solar panels. To address this, the team developed a specialized launcher that allowed them to precisely control the satellite's orientation as it left the atmosphere. Instead, they precisely machined each component so they fit together like a puzzle. The success of LignoSat has paved the way for JAXA to send more wooden satellites into space. The next step is to launch a larger satellite made entirely of wood. This next satellite will carry various experiments, including a camera to observe the condition of the wooden surface in space, a sensor to measure temperature changes, and a spectrometer to analyze the composition of cosmic rays. This technique ensures that the parts remain tightly connected even under the stress of launching and orbiting the Earth. The key to creating a wooden satellite lies in selecting the appropriate type of wood. The best choice is paulownia wood, known for its lightweight and strength. To ensure the wood's durability, it undergoes a special heat treatment process to remove moisture, increase density, and enhance its hardness. Once treated, the wood is cut into precise shapes using a laser cutter. Then it's assembled into the desired form. On the other hand, LignoSat was the world's first wooden satellite to be equipped with a propulsion system allowing it to reach an altitude of 400 kilometers above the Earth. Even though communication with the satellite was lost after 105 days, JAXA patiently waited, hoping for a re-entry signal which eventually came on day 116. Second, it helped streamline the safety assessment process for wooden spacecraft with NASA, paving the way for more wooden satellites to be licensed. Yes, it had a rough landing, but that doesn't change the fact that it broke the odds and changed the future of space travel. The satellite called LignoSat not only successfully entered orbit, it survived an amazing 116 days. That's 4 times longer than the minimum requirement. This record-breaking adventure began on September 12, 2024, when JAXA, the Japan Aerospace Exploration Agency, deployed LignoSat from the International Space Station. This tiny satellite, about the size of a shoebox, was then sent on a mission to demonstrate the feasibility of using wood in space. Despite the nail-biting moments of its deployment from the ISS, the satellite managed to send back telemetry data for over 4 months until its batteries died on December 27th. Even though the journey ended with a rough landing, it was still a remarkable success story. LignoSat had 2 major achievements. First, it proved that a wooden satellite can survive in orbit without breaking up. In fact, the idea of using wood for space exploration isn't new. It was first proposed in the early 1980s. Interestingly, this isn't the first time JAXA has launched a wooden satellite. To achieve this, the satellite had a set of solar panels and a battery that provided electrical power, a propulsion system for altitude control, and a computer system that controlled all these functions. Before we move on, please take a moment to subscribe. The technology behind this wooden satellite is fascinating. However, assembling these components poses a significant challenge due to the limited space available inside a clean room. Creating a wooden satellite is a labor-intensive process that requires patience and attention to detail. The entire project took 3 years to complete. When designing the shape of the satellite, the team faced the challenge of balancing the need for lightness with the requirement for strength. Another major challenge was obtaining precise measurements of the wood's density. Another problem they had to solve was the orientation of the satellite in space. Now let's talk about what the future holds for wooden satellites. Aside from scientific experiments, these wooden satellites will also serve an important function in space debris monitoring. The use of wooden satellites is part of a broader effort to make space exploration more sustainable. However, despite the many advantages of wood, there are still some challenges that need to be overcome. Despite these challenges, the future of wooden satellites looks bright. In conclusion, the recent successful re-entry of the wooden satellite, LignoSat now after spending 116 days in space, marks a significant milestone in the field of space exploration. This achievement has opened up new possibilities for the use of wood in space travel and has paved the way for further research and development in this area. If you liked this video, please hit the thumbs up button and share it with your friends.